back, everybody. Today we're going to talk about solving two-step equations. So far, we've been solving one-step equations where we say what is being done to the variable or what's with the variable. How do we eliminate that to get the variable by itself? In this one, we're going to have to do two steps, and the process is going to be something that we follow to eliminate everything that's not with the variable. And so I'm going to skip a couple slides here and give you kind of the Reader's Digest version. When we're dealing with these kinds of equations, we're dealing with things that have a variable that's having something multiplied by it, or it's being divided by something, we're adding or subtracting. And so there's two things that happen. First, we need to eliminate addition and subtraction. Okay, that's also going to be called zero pairs. Okay, so we're basically working reverse of the order of operations when we're undoing these things. So we're going to eliminate addition and subtraction. So for example, if we have the equation 10, can't really see that, let's see, 10 equals 3x plus 1. This blue stuff, that's going to be like this. It's going to be the stuff that doesn't have the variable with it. So that's the part that we're going to eliminate first. And we're going to do that, we're going to eliminate that by getting rid of the zero pairs. In the second part, we are going to be doing opposite operations. Okay, that's going to be eliminating multiplication and division. Okay, so that's going to be like this part here. Okay, so we basically work from the stuff farthest away from x to the stuff that's closest. So it's going to be like the multiplication part is going to be done last. It's going to be undone last. So it's like the opposite of the order of operations. So we're going to do zero pairs, then opposite operations. Let's look at an example. In this case, we have x over 2 minus 14. Let me rewrite this. X over 2 minus 14 equals 8. Okay? And so basically, we need to remember we're going to do zero pairs and opposite operations. Okay, so zero pairs, opposite operations. Well, if I look at this equation, I see here that I have this minus 14 and I have divided by 2. Well, let me cross this out so it's less confusing. My goal is to get x by itself. My goal has not changed. I still have that goal to get x by itself. And my strategy is to do zero pairs and opposite operations. So first I'm going to do plus 14. And as you recall, I must do the same thing to both sides. No matter what I'm doing, I must do the same thing to both sides. You must do the same thing to both sides. So if I add 14 to one side to do zero pairs, I have to add 14 to the other side. Put a big old fat 0 here. So this is zero pairs. And so let's look at what I'm left with. I'm left with x over 2 equals 22. Notice, I haven't done anything with that 2 yet. Now, I'm dividing x by 2. This looks like an equation that we've done before. And so to undo division by 2, I'm going to multiply by 2 on both sides. Okay, these cross out. And this is going to be opposite operations. Okay, and so what I'm going to be left with here is x equals 44, because 22 times 2 is 44. Now if I were to plug this back in, let's see what happens. 44 over 2 minus 14 equals 8. So I'm going to do multiplication and division first. So that would be 22 minus 14 equals 8. And we know that that's true. Do zero pairs, then opposite operations. Let's look at another example here. This one involves some multiplication, and they've switched it around. Well, if you feel more comfortable working the other way, you can always do this. 12 minus 2x equals 8. You can switch those around because we know that equals is equals either way. And so remember, step 1, zero pairs. Step 2, opposite operations. Goal: get x by itself. Get x by itself. And so let's work. Whether I'm working over here or over here, it doesn't really matter. I'm going to work on the side with this black because we're going to get used to seeing it like that, but you can rewrite it if you'd like. What is being done to x? Well, I am saying 12 minus 2x. Well, I need to do zero pairs first. So what zero pairs up with 12? Well, we're going to have to subtract 12 because remember, this is a positive 12, and I must do the same thing to both sides because I must do the same thing to both sides always. Big fat 0 here for a zero pair. So 8 minus 12 would be negative 4 equals minus 2x. Now, that was, can't see that, zero pairs. Okay? And now I'm going to do opposite operations. Well, what's being done to x? It's being multiplied by negative 2. So I'm going to divide by negative 2 on both sides. Okay? And this would be opposite operations. So now I have negative 4 divided by negative 2 would give me 2 equals x. If I plug that back in, 8 equals 12 minus 2 times 2. So 8 equals 12 minus 4, and that is true. Zero pairs, then opposite operations. Got a couple of examples for you to do. See if you can solve this one. It's a lot like the first one, so if you're taking notes, you can go back and look at that one. So I have 13 equals 11 plus x over 3. And in the next example, I have negative 6x plus 5 equals 23. So you can try that one too. And in this last one, I have 3/4 times m plus 1 equals 7. So see if you can do those 3 examples on your own. We'll talk about them in class. Thanks for watching, guys. We'll see you next time.